Welcome to the Network Engineering video blog. I am your host, Michael Crane. Today's video is a continuation from a video we did previously, which was the Xena Compact Deep Dive. And this is going to be the Xena Compact Deep Dive number 2. Because in the first video, we ran into some technical issues, some hardware and that didn't get upgraded because of some licensing problems. So, and also in Deep Dive number 1, which I suggest you watch because it covers more of the initial setup of the equipment than this video is going to cover. And also in that video, it was more of a, I wasn't using the manual, trying to just figure it out, which the test equipment is very, intuitive, so it's easy to kind of figure it out. But this time I thought we'd go ahead and follow the training manual that was on xenanetworks.com. And it's not really a manual, it's just a training guide. It's a slideshow kind of. It was like 55 slides, I think. What's the purpose of doing these deep dives? And would you do that in real life? And the answer is yes. Usually when you get a new piece of equipment, you throw it in loopback and you do a baseline on that equipment to make sure it's going to behave itself when it's looped back to itself. So today we're going to cover building a test packet in the Xena Manager, and we're going to be using layers 2, or we're going to be focusing on layers 2, 3, and 4, which is the layer 2 is a data link layer, layer 3 is your network layer, and layer 4 is your transport layer. And so we're going to be implementing some filters. So another thing we're going to look at today is the histogram for the test streams. And then the final thing we're going to look at, the final two things we're going to look at is going to be logging your stats for overnight, very long runs, and also charting your stats so you can kind of look at where your traffic is and what the status of it is with just a glance across the room. You don't have to go look at the numbers. You can just glance at a graph, and so we're going to look at those two things as well. So that's about it. So let's just get started. Today we're going to follow along with a guide that's on the xenanetworks.com website. So you just go to xenanetworks.com, go to resources, training guides, click on it, and we're going to be following along this Xena Manager 2G. So it says download, but it's just a I don't know, like a presentation type thing. So we're just going to scroll along here. Let's see, add chassis. We've done this. If you want to see some of this other stuff, you can go look at the previous videos on that I did on the Xena Manager and setting them up. So okay, let's see. We added ports, and we've got ports. We've reserved ports, and we've done that before. Okay, so this is where we're going to start. So I fired up the GUI, and we see I've got the chassis here, modules. Okay, yeah, we're using the default test bed, using these two ports. And we're going to just click on reserve use ports. This reserves, it says in the pop-up, reserve all used test ports. And this little checkbox right here, in case you don't know, is how you tell it what ports are in your test bed. Okay, so let's go back to the GUI here. So we're going to select a port, go to the resource properties. We're going to configure the port to accommodate your test, and it says configure the following port parameters to accommodate your test. Okay, so we're going to add 1 through 9 here, and this kind of describes what they were, and we'll go back through there if we need to answer any questions. Oh, this is IPv4 properties, Okay, and then we're going to start on the streams. So let's start with the port until we get all the way to the streams. And if we have any questions, we can come back to this document real quick. So, okay, I'm going to highlight port 1 here. That's just description. It's loaded means if you're loading it up from a file. It's an interface. It's a 10.100 1000. It's reserved by me. Included in global control. Yep. Enable TX output. Yep. And this just means it's enabled. I guess it means something if it's a fiber. Fibers you can turn on and off. I'm not exactly sure what it does for electrical, but anyway. Transmit profile. You can have normal, strict uniform, or sequential. We're going to use normal. Let's see, layer 1 control. So far as you can tell, I haven't changed anything. I'm leaving everything default. Minimum interframe gap, port speed, yep, stagger. Layer 2, MAC address, training. We're not going to pause for class of service frames, gap monitor, payload checksum, offset, random seed. Yeah, see, none of this stuff we even need to change. So really, yeah, I'm going back through. I don't see anything we really need to change. And if we do, we can come back to it later. It's no biggie. So, yeah, so let's just start. So with IPv4, which is going to be our layer 3 settings. And looking at our drawing here, we're going to have our first port, which is port 0, which is going to be 192.168.10.16. See, I'm looking at that right there. So it's 92.168.10.16. I know our subnet mask. What is our subnet mask? It is not on here. Okay, so I pulled up the original lag drawing here, and our subnet mask for these guys down here, 255.255.255.128. So let's see here. So this is going to be .128, and I know that his default gateway is going to be .2. You can see right here it's .2. Okay. So, and we wanted to reply to ARP requests, and might as well have it reply to pings. Let's see. We're not going to use the DHCP. Not going to use IPv6. Not going to use IPv4 multiclass. And the ARP NDP tables, we're going to manually add our own ARP. So that should be it for the port. Let's go through this. Oh, okay. So that should be it. The next thing is to add a stream. So, okay. So we go to, we still have our one port highlighted. We're going to do add stream. I'm just going to right click on this, say add stream. Okay, so let's see, traffic control, start. I don't need any of that right now. Port is 000, stream ID 0, test port, payload ID 0, stream number 0, it's enabled. Okay, 10% is good, just because that's a good starting point. And then this just kind of breaks it down into what that is. You see this, it's only 76 meg. Layer 1 is 100, layer 2 is only 76, and that's because of this this packet size over here. Right now it's got it fixed at 64 bytes, which is a really small packet, and we're going to change that here in a sec. And you'll see this number will change. Let's see, stop after, burst size, and we're not going to do any of this stuff. Okay, so let's see, where are we? Error handling. Yes, we want to insert the frame checksum. And let's see, error inject. We're not going to, I think you can do that when it's running. Packet size. We're gonna stay with the fixed packet size, but I'm gonna make them pretty big. Let's make them like 1500. Now you'll see that our L2 rate is real close to our L1 rate, and that's because I made the packets larger, so there's not as much overhead chewing up all your bandwidth. And we're not gonna payload type incrementing. That's fine. Connectivity check. Okay, so now it's going to talk about creating multiple flows. And I believe, oh yeah, they're just talking about adding a VLAN. I guess you can create up to 1,000 VLANs. We're gonna veer away from this document a tad at this point because we are going to create a VLAN, but that's just because I want to set the P bit. So you can read through this a little bit. It's going to be similar to what we're going to be doing. And then we're going to do some bidirectional traffic, which is basically setting up a port going the other direction. Let's see here. So we've created the layer 2 frame. And we know our source MAC is this port right here, port 0 that we're working on. The destination back port we know is going to be port 1. So you can just come over here and just say, I think this is chassis, module, and port. You don't have to set this, but I'm just going to do it to show you. We know this is going to be a VLAN. And I'll just show you. You don't have to actually set this. We'll just say none or whatever. I don't remember what it defaulted to. So next thing we're going to do is we're going to add a segment. And this segment is going to be a VLAN segment. VLAN, okay. Now before I configure this, I'll go back to this Ethernet frame here and you can see, so he already set it to VLAN. He automatically did it for you, so that's good. And, okay, so the priority bit, the drop indication, and the VLAN tag should all be 0. And we're leaving the VLAN tag 0 because that is the default VLAN when it's not a VLAN, if that makes any sense. That tells the switch it's not actually in a VLAN. But to get the P bit, which is this guy right here, you have to have this VLAN header. So otherwise you can't set the P bit, and when we start doing some QoS testing, we're going to want this P bit. So we're going to leave it just like this. And as you can see, I'm not saying what type of Ethernet it is, even though we could set it to IPv4 if we wanted, wherever it is. Oh, it's just called IP. So okay, so the next segment we're going to add is going to be layer 3. So this is all layer 2 stuff, Ethernet and VLAN. Now we're going to add layer 3. We're going to make it IPv4. All right. And before I set this, we'll go back to the VLAN and make sure. Yep, see, he automatically set it for us. Very good. Version 4. Yep, that's correct. A DSCP bit. This is another QoS type setting that we're going to come back to later. Error correction. I don't think any of this stuff we care about. Protocol we can leave the way it is for right now. Header checksum. Okay, source IP. So we know the source is .16, right? Which is port 0 we've been working on. And if we look at our drawing, so what we're going to do is we're going to come from port 0 here, and we're going to go all the way to port 1. So its destination IP needs to be this 17 right here. So we're just going to pop him in there real quick. 192.168.10.17. Alrighty. Okay, so the last thing we're going to do is we're going to tell it what type of IPv4 packet it is. And that is UDP. UDP packets are are not transactional. In other words, like TCP is a transactional type protocol. Okay, so source port, destination port. These are for not special, but for predefined ports. We're going to have our own. If we look at our drawing here, we're going to go from port 8888 to 8890. All right, because we're just going to come in through here, and let's see here. So we're going to say, oop, where'd we go here? Oh, here we go. Source port is going to be 8888. Destination port is going to be 8890. All right. Okay. And that should be it. So I'm going to go ahead, highlight the port, and I'm going to just save this. Save port config. And I'm going to call it chassis. It's in chassis. It's port module 0, port 0. I'm going to save it. Yeah, it's going to replace one that's already there. Okay. And let's go ahead and test that real quick. So if you right click, if you highlight the stream, right click on it and say preview stream. And so we're going to say start preview. This is a very handy feature. Okay, so this looks very good. Wireshark seems to be happy. I don't see any yellow or red. If we just look at the summary up here, it's Ethernet 2. The source MAC right here is 61E0. Destination MAC is 61E1. That's correct. It's here's our VLAN header. It's priority 0. It's our P-bit. CFI is 0 and VLAN ID is 0. And let's see. It's IPv4. That's correct. Source IP address is .16. Destination is .17. And our UDP, which is our datagram protocol, is source is 8888, destination, so everything's perfect. Okay, so for port 1 here, so if we right click on this and say load port configuration, we'll see how automated this is. So I'm just going to say, so it's in port, this is a port 0 configuration, right? And so I'm going to click on this guy and see what happens. Okay, warning, loaded port configuration assigns a new MAC address to this port. This may cause conflict, so we know we need to change the MAC. For most scenarios, we recommend to continue using the existing port address. Okay, so keep existing MAC address and port. Okay, excellent. So it's going to go through every one of these. Okay, the loaded stream definition with test ID equals 0, which is currently being used. So yes, we want to change to test ID equals 1. All right. Okay. Well, the first thing I see it didn't change is it didn't change the description, so that's okay. We'll just call it port 1. Loaded from that. Okay. Let's see. We'll just go through here real quick. I don't see anything change there. Layer 1. We didn't really change any of this stuff. Okay, so the MAC is right. Okay, that's good. And we didn't change any of this. We didn't change any of this. Okay, so we know we need to change our IPv4 address. So he's port 1, and if we look at our drawing here, we need to be .17 right here, right? So we know his IP address needs to be .17, okay? That's still correct. Default gateway is still correct. That's good. Okay. Oh, Do you want to change the stream definition to use a new IP address? Yes. Oh, okay. I guess maybe that's coming down here and changing the stream. And we'll just open these guys up one at a time. Okay, so the source MAC address is the 61E1, which is correct. We're on port 1. But our destination is not going to be the same port. We're going to go to port 0. Okay, so to change that, VLAN, that's correct. PBit is 0. Drop indication 0. VLAN tag ID 0. It's IPv4. Yep. Okay. All this stuff is still, it should be still the same. Okay, source IP address is .17, but our destination, we know, is going to be .16, which is on port 0. All right. So that's good. Wish we had an enter there. I never can tell if it actually saved it. Okay. Source port. We know this has changed. We're coming from, since we're coming from port 1, if we look at our drawing, so this is port 1. Our source is going to now be 8890, and our destination is going to be 8888. So our source is 8890. Our destination is going to be 8888. Excellent. Well, that wasn't too bad. As easy as Xena has made this to add all these headers, I could have probably just added them just as fast. But I don't know. It might have saved, a few 100 milliseconds or something. So, okay, so I'm going to go ahead and save this. Save port config. We're going to call it chassis. Okay, it's already got the right name. Save. Excellent. Okay, so let's go ahead and test this, or preview the stream real quick to make sure Wireshark agrees with everything we set. And let's see here. And so Ethernet, the source is 61E1, that's correct. Destination 61E0, that's correct. PBit is 0 and our VLAN. Drop indication 0, and VLAN ID is 0. It's IPv4, that's right. Source address is .17. Destination address is .16, that's correct. And UDP source port is 8890, and our destination is 8888. Okay, so I guess it now is about as good a time as any to start the traffic. So, start traffic. Well, it only did it on one. Start traffic. I know there's a way to globally do this. I never can remember where it is. We'll figure it out here in a second. Okay, so we started traffic on both these ports. Let's see. Let's look at some global stats. This is for the port. I wonder if I could stop the traffic globally here. Ah, here we go. So if you go to global stats, you can start and stop the traffic for both ports. Okay, let's see. Transmit. Ah, here we go. Receive. So port 0. He's transmitting, 100%. I guess that's layer 1. Or here it is, layer 1. Layer 2 is 98. Here's the packets per second, bytes. And he should be receiving exactly the same thing, which it looks like he is. Alright, and I'm sure if we had any drops, traffic out payload, filtered traffic, ARP, we didn't do any of that stuff, injected errors. Okay. Oh, very good. Okay, so we're going to add a filter now. Okay, so filters are used in order to get statistics on specific types of packets, either specific content or specific packet size. These filters can also trigger the capture mechanism or focus histogram results. So I'm going to click on filters. I'm going to add match term. 2, click to access the field you want to match. Maybe it'd be easier just to look at the pictures and if we have any questions. So, okay, they got source MAC, destination MAC, VLAN tag, IPv4, IPv source, destination, and then TCP. So we know we're not going to use TCP. So I'm going to just add all these at one time. How does that sound? So add, okay, source MAC, okay, select field, add segment, VLAN, okay, which is something we really don't need, but we can go ahead and add it anyway. Okay, and let's see what else the picture's got here. IPv4 source, IPv4 destination. Okay, we'll add those two. So, where's it? Add, select, add segment. We want IPv4, okay. We want IPv4 source, okay. Add term, select field, add segment. Wow, this can get old in a hurry, huh? Okay. And we want destination this time. Okay. Let's see, what else is on here? Oh, the last thing was TCP source port. So we're going to do, I'm not going to use TCP. We're going to use add segment. We want UDP. Okay. Oh, wow, that's interesting. UDP checksum. I don't think we want the checksum. And we want, we'll do the source port. So 3, filter mask. They've got, so let's look at this real quick. 3, position is set to beginning of a field. Example, if you want to match last octet of IP, the offset should be incremented manually. Mask to focus on a specific byte. The other should be set to 0. It looks like it's got a default stuff in here. Maybe we should just leave it like that. What is this? Well, everything else, let's see, the source or the destination is FF and a bunch of zeros. So that's right. And our source is, they have FF and a bunch of zeros. We have all F's, which I guess it means it's going to look at all the source MACs. And then this VLAN tag, okay, they got 0F and then FF, that's right. It looks like other than the source MAC and the source IP address, everything else, well, this destination is not the same either. I'll just keep it like that for right now. So 3, the mask to focus on a specific byte, there should be set to 0. Okay. Value. The value you would like to match. The value is hex, so 50 decimal equals 32x. Got it. Well, we'll come back to that if we need it. Length term used to find the specific packet sizes. 5. Oh, add length term. Okay. And we're going to say at least 1500. Okay, I sure wish we had an enter around here somewhere. 6 is add the filter. So let's say add filter. Okay, so this is going to filter whatever packets we have. I guess if you had a whole bunch of packets you needed to match on. I guess these are buckets that count how many illegal packet sizes and VLANs and stuff like that. So let's add some of these. Filter condition. Build a filter based on pre-built-in terms using the AND, the pipe, and the tilde. And then it gives some examples. So they had 2 examples. They had this one up here, which is a legal packet size, L0 piped. I guess this is like an OR. L0 or L1. I'm guessing this means and. This is OR and this is a NOT. If it's anything like programming languages. So let's see what they got here. They've got source IP. Okay. They've got M3 and M4. Oh, okay. Here we go. So here's the match terms. M3, M4. VLAN ID 100. VLAN ID, which is just M2. And runts is L0. Oh, okay. Length terms. Oh, I kind of like this. So L1 should be good packets. Legal packet size. Legal packet size is not L0 and not L1. So I guess what they're saying is their max packet size should be under 1500 and over 64. So anything legal is going to be not under or over. So it's not L0, so it's not this guy, and it's not this guy. So maybe I need to change, we'll say at least, since ours is 1500, we'll say at least 15, or maybe 1501. Okay, so if it's at least 1501, it's too big. And add filter. Oops. Now we need to add length. Where is it? There it is. Add length. And if it's at most $14.99. That's going to be kind of silly, but let's give it a shot. And so we'll just call this good packets. And it's not L0 and not L1. All right. Okay. See if we understood that. Okay, then we got runts and jumbo. Okay, so let's make this guy runts. And that would be, runts would be L1. Okay. Man, I wish we had a add or a save around here. And then add, I'm going to call this jumbos. And that's going to be L0. Right? Because it's anything at least that big. Okay, what else they got here? And then a legal packet size is L0 or L1. Oh, okay. I need to add filter. And that's going to be L0 or L1. Okay, so the next thing is let's look at our filter results under global statistics, port statistics. Filtered traffic. Okay, port 0. Let's see, filters. Click, click, click. Okay. All right, global statistics. Here we go. Good packets. Well, look at that. Everything is good. Okay, we're going to inject a couple more errors so we can go back and look at the stats and make sure we can find them and identify them. We already looked at this frame checksum, so we know that how to read that. We know it comes in as 2 errors if you inject it. I'm guessing if you receive one from the system under test that you'd only get a count of 1. So let's see what else we got. We got a sequence error. This is where it's a packet's out of sequence. I'm guessing it's a packet, not a frame. That would be crazy. Let's see, inject error. Let's go over here to the global stats. We did receive an error. Oh, here we go. Stream stats. Ah, I bet you it's under here somewhere. Let's see here. Lost packet. It shows 1. Okay, so let's go back over to stream, resource properties. So we didn't see a sequence error. Misordering error. Global stats. We see it misordered. Lost packets, misordered. I guess these are receive errors. I'm not reading this real well. And I could go to the... I'll have to go to the document and look and see what that is. So let's go to resource properties, payload, test payload error. Let's do payload integrity. Okay, global stats, payload error. Okay, resource property, test payload, global stats. Oops, I forgot to insert it. Test payload, global stats. Oh, okay, it just shows up as a lost packet. Okay, so we know that if we inject a test payload error or a sequence error, it's gonna come in on the stats as a lost packet. We'll just have to keep that in mind. The next thing I wanted to look at is on these filters right here. We've got jumbos, illegal packet size, runts, and we haven't really pegged these yet. We've got it real tight, which is not going to be real world. We'll have to adjust that probably when we go to test, but I want to go ahead and make sure that works okay. And the only thing I can think of is I'm going to add another stream. I'm going to say add stream, and we're going to just configure it here real quick to we're going to send it. It's going to be a very small amount. We're going to say 1%. All right. Okay, so we set mix sizes, and now we have to go to the port properties. If I read the instructions right, it says mixed weight sets can be loaded, saved via the port resources property. So we need to go from the stream to the port and to save the mix set weights. Okay. So I'm just going to say 0, 0, 0, 0, 0, 0, 0, 0, 0. And I'm going to make this guy 50. So these will be our jumbos. And 512 will be our runts. He's going to be 50. The sum of packet weights is currently 50%. See? I need a save button. See, I couldn't click anywhere on here without it saving. Okay. So we got 50% at 512, 50% at 1518. That should, and we're sending them at 1%. So that should trigger jump. We should get half of them should be jumbo, half of them should be runts. And I don't know how much of this other stuff. We'll go ahead and set it. It's pretty quick anyway. So our destination is 1, and I'm only going to do it one way, so we don't have to mess around with it too much. Let's see, add segment. We want VLAN. Oop, where is it? VLAN, okay. Yep. Add segment. We want IPv4. Okay. Yep, source, destination, 192.168.10.17. Yep. And let's see, what's the last thing? Oh, we need add segment. Let's say UDP. So these are basically going to be the exact same thing as what we're doing, but they're just going to be different sizes. So the source is 8888. Destination is going to be 8890. Okay, let's go ahead and I'm going to preview this real quick to make sure that it's I didn't miss anything. This is a really sweet feature right here. Okay, source is 61E0, destination 61E1. Yeah, P-bit is 0, CFI is 0, ID is 0. Source is .16, destination is .17, source is 8888, 8890 for UDP. Excellent. So yeah, now let's go ahead and start this traffic. Start traffic. Now let's go to our global statistics. Port stats. Ah, there we go. Clear counters. Why aren't these? They look like they started to go up. Now they're not working at all. Oh, I need to be on port 1, don't I? No? Port 0, aggregate. Did I only turn the filter on for port 0? Let's see. Filters. Global stats. Stop traffic. Filters. Oh, I guess I only did it for port. Well, dang nabbit. Okay, so I'm going to go ahead and copy stream. Let's see if this works. Paste single stream. I've never tried this before. I have no idea if it works. Well, we've kind of went wheels off with this whole following the user's guide, haven't we? But this is the best way to learn your equipment. Okay, sir, let's see. We're on stream. Let's go into resource properties. Ethernet. So destination is going to be 0. I'm just going to go through this real quick. All this stuff should be okay. We need to change the destination to .16. And I wish I had an enter around here somewhere because I have no idea where to click to make it accept that change. And UDP as source is going to be 8890 and destination is going to be 8888. Okay. Now let's go to global statistics, start traffic. And I still don't see it. Oh, maybe I need to go to the port. Stream 1.3, mix sizes, yes. But I didn't set the weights here. I would have thought we would have still got some stats. I don't know why this isn't working. 0, 0, 0, 0. I'm going to make this 50. 0, 0, 0, 0, and 50. Enter. Yep. Okay. Once again, I'm just going to turn on this one port. Go to global stats. Okay, so the only thing I can think of is in our filter up here. Oh, sorry. In our filter for port 0, we didn't set a filter value, which is a matching, what to match on. This last bit, we're going to set to E1. And so it's E1, okay. I don't understand why I can't preview it. I can remove it, I can do everything, but I can't. I'm gonna just start the one port, which will get both streams. So okay, so let's go back over here to port 0, global stats, and yeah, we're still not getting anything. I couldn't figure out what was going on, so I deleted this. There was something wrong because when I couldn't preview the stream, I thought something was wrong, so I went ahead and deleted this stream and just added it manually, similar to how I added this one. I did it off camera because I was just poking around trying to figure out why the preview didn't work and why the stats weren't working. So anyway, I got the stats everything working. So if I start the traffic, go over to global stats, as you can see, we've got 100 meg of good traffic, and we've got about 10 meg of bad traffic, which is exactly what we said. Half of them should be jumbos, half of them should be runts. It looks correct. At least they're both adding up to 10 meg, which is exactly what we set it for. And the packets per second, 605, 604. So that's exactly what we expect. So I'm going to go ahead and skip over all this capture training because we'll do that when we go to debug it. We'll probably get plenty of experience. But there is some pretty interesting triggers that you can set in here. I suggest you read it. So next thing we're going to do, though, is the histogram. And hopefully we're going to go through this pretty quickly because this video is already getting long. And let's just see what we can set here real quick. So I'm going up here, I'm going to click on histogram. So let's just do this real quick and see if we can get a graph. Okay, let's just start it. And, well, I'm not seeing anything. Stop. Let's try to plot something else. How about length start? Okay, well that looks a little better. Well, this kind of makes sense. So we've got most of our packets are at our 1500 bytes, and we've got these jumbos here at 1518, and these over here at 512. They come in a little more handy. Come in handy when. Especially this latency and jitter when we go to do some testing. Okay, so next on the list is in the training manual is the global statistics. I'm not going to really go over these. You can read through them. We kind of reviewed them a little bit just by playing around. There is one thing I wanted to do, though, and it's kind of weird. It's under global statistics, but it's the logging, and I have to wag my finger at Xena for this. This took me probably 10 minutes to find. Maybe it's because of the of global statistics header on the slide threw me off, but I kept looking around. I was in global stats. I'm looking at all the tabs and check boxes, and I just couldn't find it anywhere. And I finally, I was looking through all the menu options. I just couldn't find it. And finally, I came down here and saw the statistics logging. And clicked on it, and I finally found what this is talking about. And to enable it, you just highlight the checkbox, and logging is good for a couple things. One, if you're doing some overnight testing, you can see what's going on. If you have an outage in the middle of the night or something like that, you can kind of track down what happened. Another thing is I believe, and I could be mistaken here, but you need it turned on for the statistics. I could be wrong. So select types. Oh, good. Everything's selected by default. Good. And logging. Let's see. 1. Prefix that will be used for log file name. Stats log. That's good. Select file name with or without timestamp. Yep. Select to separate files by directory. I don't know if I want that, but we'll leave it since it's default. File type, CSV or XML. Yeah, CSV is better. I don't have any traffic running, but let's go ahead and start logging. And let's go ahead and go to our global stats and start traffic. Okay, good. It started on both of them. And this should be running. And now if we stop logging, oh, here we go, current log directory. So let me go pull this guy up real quick. And got a CSV file. And what's nice about this is it should pull up a Excel spreadsheet. So excellent, very good. So let's look at the stats charting. Now see, look, so I want to go over here to the I go over here to the stats, and if you drag over any of these other guys, so you either have to come down, you can't go just sideways across it. Let's look at the training guide here. See, statistics charting. Add chart, step 1. Okay, so let's add the chart. Oh, you can't select more than one? Oh. Okay, so, okay. Step 1, step 2, step 3. Oh, start charting. Okay. There it is. Okay, one thing to note when you start this charting is mine defaulted to something other than what I selected, and it actually put it up under. It put my transmit underneath what its default was, and it kind of confused me at first. I did it off camera. I was kind of playing around with it and didn't get to show you. And also there's a tooltip that's defaulted on. See the show tooltip? And I guess that's nice. It really needs to be off to the right. It doesn't need to be right smack dab in the middle of the cursor, because if you're trying to highlight a divot in the graph, you can't find it because you got this pop-up box blocking where your mouse is. So I've just been turning it off. Anyway, yeah, our charts are running now. You can add more charts. So you just click on Add Chart and just select whatever you want, and it just pops it down underneath what was currently set up, and you can scroll around. But you can also add a second chart inside it. So we could add this receive right here, and so it's got the left legend, the right legend. My guess is it's hiding up underneath. Okay, to remove a chart, you just click on remove. And so we only have one chart. I am very confused on what these are. I'll have to go read, but this is port 000, chassis module port number, I guess, stream 0. I guess that's what that S stands for, but on the right one it says T1. And it's not transmit. I don't know what that T means. What's nice about charting is you can just glance at it from across the room and see if there's any problems. So we're going to add a second. Oh, there it is. Add second. We're going to receive frames per second. I'm going to remove this or turn off this tooltip for a second, and I'm going to unplug the loop back real quick and then plug it back in. We should get a dip in our receive. I doubt if it would affect the transmit, but we'll see it. Maybe when the port goes offline, it'll affect the transmit as well. Okay, so I broke down and and got the user's guide out for the Xena Manager 2G, and I read through this whole section on charting, and nowhere does it explain what T or S stands for. And the only thing I can think of is this is stream 0 that it's graphing on port 0 and 1 on the transmit side, and on the receive side it sees that, okay, I'm getting test ID 1, and so he's saying, okay, this is test ID 1, I'm receiving test ID 1 on port 0 and test ID 0 on port 1. And I know that's super confusing, but anyway, that's the only thing I can think of. Maybe Xena will chime in and explain it to us. Okay, so I went ahead and added a second stream on port 1, and to confirm my guess, and it looks like I'm right. So on port 1, stream ID 1, I guess this is the transmit, and on port 0, it's receiving test ID 2. And like I said, I'm still guessing at that, but it kind of makes sense. But they definitely need to add that to the manual. That would be very helpful. So one last thing about this this charting, and the reason why I was thinking maybe it was you had to have the statistics logging going on at the same time as the charting is I've seen other test equipment. So if you find let's say you find a divot in your graph and you want to go to where it is in the log file, a lot of test equipment you can just double click on that point and it'll take you to that event in the log file. So the next thing on the list is in the training manual is the event log, and port link issues, packet loss, log packet errors, service disruptions. Yeah, that's kind of nice. Let's see, where is that thing? It's communication event log. This is an info. Can you double click on it? No. I guess that's all you get. So, okay. Yeah, that's okay, I guess. And then communication trace, I think that's next. That's just it talking to the appliance from the GUI, and that's the end. So, okay. I'm feeling pretty comfortable with this test set now. I think the next step is we need to tie it to some test equipment or system under test and start running some traffic. So I hope you like this video. If you have any questions or comments, leave them in the comments under the video, and I will try to answer them the best I can. And I'll see you later.